Welcome to this brief demonstration of CyberMapper's VisualOps latency feature. My name is Mark Leclerc. I'm NoviFlow's VP of Strategy and Marketing. CyberMapper is being used around the world to scale multiple different network services. These include threat intelligence gateways, packet brokers, load balancers, and also various other network functionalities, including in-band network telemetry or INT, SRv6, and others. In the present demo, we're going to have Alex Bien-Aimé, NoviFlow's solution engineer for the CyberMapper product, to demonstrate how the visual latency interface works and how customers could benefit. So without further delay, here's Alex.
I'll give a quick summary of what we see on this page. So on the left is the red is the untrusted traffic coming into the switch. On the bottom would be the traffic that's gone through the firewalls and would be the trusted traffic. On the bottom would be the average latency generated by all the traffic tools. If we check the section on the right, you have a card for each of the firewall tools that we configured earlier. On the top is the red is the ingress traffic, the red coming into the firewall, the green, the traffic after it's been through the firewall, and on the bottom would be the latency generated by this firewall, thanks to the in-band network telemetry, which are metadata information we attach to packages after they come into the switch before they go to the tools, and then that metadata is popped off the packet, sent to an engine, an analytics engine, where we do processing to calculate the latency. And before sending it out the switch, that telemetry data and metadata is removed from the packet and sent out. So right now I'm going to start some traffic, and we should be able to see that traffic on the dashboard. As you can see, we're getting traffic that's being load balanced across the 3 tools, and it's giving us the latency data on all that traffic. So these 3 target tools, I'll explain right now what they're going to. So in the middle is a loopback, which is the baseline. So it gives you this latency of the actual switch. This is why you're almost seeing a flat line. And there's almost no latency, which is it's averaging at about 843 nanoseconds. On the left, the target is a FortiGate firewall configured with minimal security policies, and the latency is currently generated is about under 100 microseconds. And on the right is going to a second FortiGate firewall, but this time configured with a lot more security policies, strict security policies. And you can see that the max latency it reached was actually 5 milliseconds. And I can tell you from experience that as you send more traffic to one of these firewall tools, latency goes up. So there's a correlation with how much traffic and how much latency is generated. So knowing this, you could react and make sure that you respect your SLAs on latency. And for instance, if you reach a latency threshold, you can decide to add more virtual FortiGate firewalls to make sure that you don't pass a certain latency threshold.
Thank you, Alex. A typical use case for a mobile operator would be to deploy CyberMapper's capability for monitoring latency of services in either the backhaul or at the GI LAN level. In the backhaul, operators could utilize the latency measurement capabilities of CyberMapper to prove that service level agreements with customers were being met, and also to be able to monetize services based on their on-time performance. In the GI LAN, the operator could utilize this capability to verify that service level agreements with their own service providers were being met. We thank you for taking the time to view this demo, and if you have any questions, please make sure to visit our website at www.noviflow.com. Thank you very much. Good day.